All right, checking in. A little bit different format here might perhaps help. At least get some people started here today. I am now showing the difference between two all claims. They're actually the converse of one another. You don't have to know that term, but it is part of what I discuss and talk about, and it may be interesting or helpful. If you look to the left at the top here, we have all K are L, and I have shaded out areas 2 and 3. Shading means you don't have anything in that area or of that type, as I've said at various points. And what we don't have, if all K are L, is something in 2 or 3. The K's are pushed into the L area because all of them are L's. It's crucial if you aren't clear in your mind about what shading as opposed to the X's or marks are. You're kind of dead in the water here, and it's going to be a disaster. So make sure you know the difference between marks and shading. X's and shading. Over on the right, notice how it changes if we say all L are K. All the L's are K. The method, a good method anyway, is take a look at the L's. Forget about the other circles. L's are areas 5, 6, 7, and 8. If all those things also have to be K's, you couldn't have any that aren't K's. 7 and 8 get shaded out. Going on to a couple others here. On the left, we have no P or Q. And if no P or Q, we can't have any P's that are Q. We can't have anything that's both P and Q. That would be areas 6 and 7, and so we shade that out like that. Now, and this is the way your mind should go as you train it, we shift gears a little bit to a sum claim, saying we have something of a certain type. Not what we can't have, but what we do have. We have some X that are Z, a little bit sloppy here, or a little bit hard to read, but hopefully you know the numbers at this point, or can understand what I mean in any case. If some X's are Z's, we have something that's both X and Z. There are 2 areas on our diagram to the right here that are both X and Z. That's 5 and 6. X's that are Z's come in 2 varieties. Ones that are Y's, that's area 6, and ones that aren't, that's area 5. We have no reason to assume one or the other, so we have to cover our bases here and make no extra assumptions and make a mark between 5 and 6. Incidentally, for Aristotle, what we would add for the all and no claims, that's only when it's different, would be a mark. Let me say quickly, if we look up top here, all K or L, well, we say, well, what if I have a K? Where would it be? Well, it's either got to be in 5 or 6. It's got to be in L. So you just make a mark with a circle around it between 5 and 6. That's for Aristotle. All L or K, the mark's going to go in the same place, actually. In this case, no P or Q. Here we need 2 marks, as I discussed in the book and in the other videos. We got a P. In virtue of mentioning P's, we must have one. Can't be in area 6 or 7, so it has to be in 3 or 4. So we'd have a mark with a circle around it between 3 and 4. We also have a Q, and it can't be in 6 or 7. The remaining areas of Q's are 5 and 8, so we get a mark with a circle around it over there. Don't worry as much about what to add on Aristotle's interpretation. It's important to note, as I just did and have otherwise, it's only different for a shading claim. In all or no claim, it more comes into play as we put this all together down the road, but I wanted to talk it out a little bit as we go along. Let's move down and take a quick look at these last 2. All right, right here we get some X or not Z, and that says we have something, it's X and it's not a Z. So you can take some time and get used to it. The X's that are not Z are indeed 4 and 7, and so we have a mark between those 2 areas, as is pictured. By contrast, maybe this is helpful, if instead it said some Z are not X, we're looking for something that's Z rather than not Z, and we're looking for something that's not X rather than is X, and that winds up being 2 and 5, as is pictured here. A method you could use, look at the Z's, 2, 3, 5, and 6. You have something in that circle, and it is not an X. So it can't go in 3 and 6. What's left? Those things that are not X. It's 2 and 5.